one ring also possible. One ring. See, degree of unsaturation 1 is there. Degree of unsaturation 1 is there. Suppose in the examination, they may ask you only molecular is equal to 2 is the given molecular formula. So what are the therefore how many double bonds are there? Two double bonds are possible. How many triple bonds are double bonds are possible. So we can find out easily with the help of double degree of unsaturation. Degree of unsaturation. So 1 triple bond. D also possible. Degree of unsaturation or double bond equal 1 pi bond is equal to 1 pi 1 plus D is equal to 1. It meaning is therefore also is possible. One double bond is present. What is the one more possibility? Two rings one double bond is present in the given molecule. Two rings also possible. And Du is equal to 1 is the double bond. There is in your molecular formula one double bond will come. One ring also possible. Next, Du is equal to 2 will come. There is a two double bonds will be there in the given molecular formula. RS one triple bond. You know, two double bonds are equivalent to one triple bond. One triple bond is equal to two double bonds. And what is the one more possibility? One pi bond with one ring. So one ring will be there like this. One ring, one pi bond also will come. Now this is called one pi bond with one ring. And one more possibility, that is the two rings also possible. So this is the about Du is equal to 2 is 3. Du is equal to 2 is 3. Next, for example, there is a molecular formula C2H. We will see simple to complex. Simple example to difficult example. What is the Du formula? Du is equal to degree of unsaturation. It is a 2 into Nc plus 2 minus NH upon 2. Here, Nc is equal to number of carbon atoms. Number of carbon atoms. Next, NH is equal to number of hydrogen atoms. Number of hydrogen atoms. So this is our given molecular formula C2H4. So the 2 into how many number of carbons are there? 2 plus 2 minus number of hydrogen atoms are 4 upon it is a 2. So what is the answer, students? 2 into 2 4. 4 plus 2 6. 6 minus 4. It is a 2. 2 divided by 2. What is the answer? It is called 1 degree. So what is the answer? I got 1 degree. Du is equal to 1 degree I got. It meaning is one double bond is possible, one ring also possible. See that. How I am going to write after getting an answer. So that CH2 doubly bonded, it is a CH2. CH2, it is a one CH2. So this is called degree of unsaturation. Unsaturation 1 degree. Next, C3H6 is the C3H6. But here the formula will be written. So 2 into Nc plus 2 minus NH upon it is a 2. So number of carbon atoms are 3 plus 2 minus 6 upon it is a 2. So here you have to remember one thing. I got 1 degree, degree of unsaturation 1 degree. So I have written this is the formula. But with this molecular formula, we can't construct the ring it is, except this molecule. Now see that I have taken C3H6 molecule. Here, what is the answer here? So 3 2 is 6, 8, 8 minus 2. Here also 1 I got. So degree of unsaturation 1. See that? This will be written 1 propene CH2 doubly bonded CH single bond, it is called CH2. How many pi bonds are there in the given structure? 1 pi bond is there. It is called D is equal to 1. See that? Now I'm going to write a ring form also. See that? D is the ring. D is the ring. So double bonds are equivalent to ring. Which ring it is called? Unsaturated hydrocarbon. So that one ring is there, it means that, see that molecular formula is same. Here also same. Number of carbon atoms and number of hydrogen atoms are same. But it is called open chain. It is called a ring form. So that what is the degree of unsaturation for rings? Here one ring is there. It is called 1. It is also one pi bond is there. So that what are the possibilities? One double bond is possible. One ring also possible. Next one is, we'll go for one more example that is called a very familiar example that is called benzene. It is a C6H6 benzene formula. So this is the structure of benzene. Double bond, double bond, double bond. Alternated double and single bond will be there. Can you tell me how many pi bonds are there here? Number of pi bonds is equal to 3. How many rings are there? Number of rings. It is the number of rings is equal to 1 is there. So that what is the du? Du is nothing but it is the number of pi bonds plus number of rings. So what is the answer, student? It is called 4 degree. So that degree of unsaturation for benzene is equal to 4 degree. You can apply same formula here also. There is a degree of unsaturation is a 4. Suppose if the degree of unsaturation, if du unsaturation is greater than 4 or equal to 4, the structure, so the structure will be one benzene ring will be at least one benzene ring. See that in some of the complicated structures, du is greater than 4 also will come, du 10 also will come, du 15 also will come. In that case, we can, so the structure will contains at least one benzene ring will be there. That is the meaning. So degree of unsaturation 4 or greater than 4 is the your molecular formula which contains at least one benzene ring, that is called du. And the greater than 4 or equal to 4 is the structure will contains at least one benzene ring. For example, we will see one example. Suppose this is the example they have given in the example. C triple E bonded, it is CH. Here one double one. So it is CW bonded with C. Can you tell me? Can you find out how many pi bonds are there? So du is nothing but this is one of the complicated structure. Du is equal to therefore number of pi bonds in that cases number more than one benzene ring is the number of pi bonds. Number of pi bonds plus number of rings are number of rings it is. Number of rings. This is the formula which we are using. The molecular formula contains more than one benzene ring. Now see that how many number of pi bonds are there, students? So here between the carbon triple bond is there. Here 2 pi bonds. Here one is there. It is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is there. Here 11. Here also one functional group is there. It is called C, W bonded one. It is called OH. Now tell me total how many? Now here also one pi bond will come, right? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Number of pi bonds is equal to 12. How many number of rings are there? This is the one ring. It is a one ring, it is a one ring, it is a one ring. Total number of rings is equal to 4. So that therefore du is equal to 16 will come. See that? It means that just now we discussed du is equal to 4 or greater than 4 is there. The molecular formula or structure will contains at least one benzene ring is there. That is called du. Next, one more example. This is the previous year question, previous JEE question. Example 2. Your structure will be like this. Here nitrogen, here it is CH3, here is a COOH acid group, double bond, it is NH2, here I attached. Here one Cl, CH, W bonded, NH, here it is CH1, aldehyde functional group, here it is CW bonded, it is NHCH3, NHCH3, so it is called CW bonded. My dear students, guess it how many number of pi bonds will come here. So here it is a number of pi bonds plus number of rings is nothing but your du. Number of pi bonds plus number of rings is nothing but du. What is the du here? Du is equal. Now here one pi bond is there, and here also one pi bond is there, and it is CW bonded OH. This will be written like this also, no? It is a OH. Here also one pi bond. Here also one pi bond. Carboxylic group will be written CW bonded OH. So here 1, 2, here also 1, 3, here CHO group will be written like this also, CHW bonded O, this group, okay. So the here also 1, 2, this is 3, 4, it is a 5. Number of pi bonds is equal to 5. Number of rings are there, it is a 1, it is a 2, it is a 3. So the total number of rings is equal to 3. So du is equal to 4 will come. So that it is the du is equal to 4. Say that du is greater than 4 or equal to 4 is the structure at least contains one benzene ring. Suppose in the molecular formula, if there is a monovalent atom, divalent atom, trivalent atom is there, then how to find out the du? See, how to find the du? Before that, okay, suppose there is a example. This is the molecular formula they have C6H6. So 4 2s are 8, less number of 2 hydrogen atoms, so that it is one of the alkene. So it is one of the alkene. It is called alkene. The given molecular formula is alkene. Alkene mean 1 triple bond will come. Right? Now we will apply the formula. Du is equal to, what is the formula is there? 2 into Mc plus 2 minus NH upon 2 it is. Tell me 2 into 4 carbons plus 2 minus number of hydrogen atoms are 6. So that 4 2s are 8, 8 plus 2, 10, 10 minus 6, 4, 4 divided by 2. So that degree of unsaturation, this is the du is equal to 4 I got. Tell me, very beginning I said, what are the possibilities are there here? One is the possibility, 1 triple bond is possible. 1 triple bond is possible, right? And what is the one more possibility? 1 triple bond is equal to how many? It is equivalent to 2 double bonds. So that here 2 double bonds also possible. 2 double bonds. 2 double bonds also possible. 2 double bonds are possible. Here one more also. one ring with pi bond also. Pi bond. One ring with pi bond also possible. See the one ring means du is equal to 1 with pi bond, 2 pi bonds will come. Sorry. One ring plus 1 pi bond. So du is equal to 4 will come. Next, two rings also possible, students. Two rings also possible. So my dear students, so with the du2, I got these the possibilities. One is called 1 triple bond. 1 triple bond is equivalent to 2 double bonds. And here one ring with 1 pi bond also possible. Two rings also possible. Let us see after getting the possibilities, okay? Then we will start the writing the structure. First one is called, we'll move on to first one. 1 triple bond compound. See that? With the 4 carbon atoms. Now it is called CH3. It is a C triply bonded. It is a C. Now it is called CH3. So what is the name? It is called 2-butane only. Na? IUPAC name is given 2-butane. Next one. Second one we will write 1-butane also. So 1-butane. This is called 1-butane it is. So 1-butane. 1-butane. What is it? So is there any other possibilities, sir? So 1 and 2 are which type of isomers, sir? It is the 1, 2, 3, 4. 1, 2, 3, 4. Both are position isomers, students. So it is over. Third one is, we'll move on to, we'll check it. Two double bond compounds. Two double bonds compounds. See that it is CH2, W bonded, CH, CH, W bonded. It is the CH2. Now, here how many double bonds are there? How many pi bonds will come? Double bond or pi bond? Two pi bonds are there. So the two pi bonds is equivalent to one triple bond. And next one is, we will write fourth one is, see that, 1, 2, 3, 4. The double bonds are located at first carbon atom as well as third carbon atom. Now, I am going to keep two double bonds on adjacent position of the carbon. It is also possible, students. Now it is also possible. See that 1, 2, 3, 4. Now it is called 1, comma 3. Now it is called butadiene. It is butadiene. Now this is called 1, comma 2. Butadiene. Butadiene. Di mean 2. Double ones are 2 order. Next one is, these are the over. Next, one ring with one pi bond. One ring with one pi bond. Total how many carbons are there? 4 carbons are there. So that one ring is over, D is equal to 1, one pi bond also is there. Right? Next one is sixth one. Now this is called cyclobutene. Now I am going to decrease the size of the parent chain. I will keep 3 carbons in the parent chain and one methyl will be on the side chain as a side chain. Now here one double one. See that? One pi bond is there, one ring is there. So that this will be written, one more it is, seventh one is, will be written like this also. One more, one double bond will be here. It is also possible. Now what is the numbering? 1, 2, it is a 3. So that it is called 1 methyl it is. 1 methyl cyclopropene it is. 1 methyl cyclopropene. Here 1, 2, it is a 3. This is called 3 methyl cyclopropene it is. Propene. Now this is called cyclobutene it is. Cyclobutene. Next, what is the one more possibility? So that this is the possibility. Now the double bond will be out of the ring it is. Now it is 1, it is a 2. What is the name? It is called methylene. Methylene cyclopropane. Cyclopropane. Why I have written like this? Because the substitution is the longest carbon chain. Here 2 carbons are there. Now what is the substituent here? Methylene. Methylene cyclopropane. Next, this is also, next one is called two rings are there. Now this is called bicyclic compounds. Now I'm going to write like this. Bicyclic compound, see that, this is the ring. Now see that numbering is given. It is called bicyclic compound. Within the bracket, here one carbon, here also one carbon, one dot. And next one is here also one dot. And next one is the number of bridge carbon atoms are 0. Total how many carbons are there? It is called butane. It is called butane. So that it is called 1, it is a 2, it is a 3, it is a 4. So in case of bicyclic compounds, the name is started by cyclo. It is called by cyclo 1 comma 1 dot 1 dot 1 dot 0 butane. So I got these are the different isomers with the molecular formula. With the molecular formula C4H6 students. What is the du I got? It is called do. It is called du is equal to. So what is the possibility? 1 triple bond, 2 double bonds, 1 ring with 1 pi 1, 2 rings also possible. Next, in case of monovalent is present. Suppose in your example, the monovalent atom is present. If any monovalent atom is present. Monovalent atom means like halogen atoms. If any monovalent atom is present, monovalent atom is present. Monovalent atom is present. Then we'll see example. It is a C2H5. It is a Cl. I will go for it is a X. X is equal to, it may be chlorine. It is a chlorine, bromine, iodine. These are the called monovalent atoms. It forms a single bond. In case of monovalent atom, to find the du, we just remove all the monovalent atom and add same number of hydrogen atom. So that remove all the monovalent atoms and add same number. How many you removed? Equal number of same number of hydrogen atoms are added. Hydrogen atoms added. Equal number of hydrogen atoms are added. See that. The example is C2H5. It is a Cl is there. C2H5 Cl is there. Now this is called monovalent atom is there. I am going to remove this to find the du. Remove all the monovalent atom and add equal number of hydrogen atoms. See that one chlorine is there. After removing the chlorine, so this formula is modified like this. You want to find out du to this compound. So what is the du nana here? Du is equal to 2 into 2 plus 2. It is the minus NH means 6 hydrogen atoms are there. It is upon 2. So what is the answer? 2 into 2, 4, 6, 6 minus 0. 6 minus 6, 0 by 2. What is the answer? Degree of unsaturation, 0. It means that the compound is a purely saturated hydrocarbon. So I got answer is 0. It means that your hydrocarbon is a purely saturated hydrocarbon. So that we can't write a different isomers, right? Next one is one more example we will take. That is called C6H4. It is the Cl2 ester. Here total how many chlorine atoms are there? That is called 2 monovalent atoms are there. Remove all the chlorine atoms, monovalent atoms, and add equal number of hydrogen atoms. So that after removing the 2 chlorine atoms, I got is C6H6. Just now we calculated what is the du for benzene. Du is equal to, so 3 rings will come. Sorry, 3 pi bonds, 1 ring will come. This is called 1 ring. Now this is called the number of pi bonds is equal to. What is the answer? It is called 4 degree will come. So that du is equal to 4 or greater than 4 is the your molecular formula should contain at least one benzene ring. Next, one more example that is called C2Cl2 is the C2Cl2. So that after removing of this one, I may get it is the answer C2H2. What is the du? Du is equal to 2 into 2 plus 2 minus it is a 2 divided by 2. So 2 into 2 4 6 6 minus 2 4 4 by 2. What is the answer? It is called 2 degree. So we got 2 degree. So what are the possibilities? So one ring is possible. It is a one triple bond is possible. One triple bond is possible. This is the one possibility. Next, two double bonds will possible. Next one is one ring, one pi bond is possible. Two rings also possible. So based on the formula, we can write down the structure of this compound. Next, in case of divalent atom, is next case 2. In case of divalent atom. In case of divalent atom is present in the molecular formula. We can use same formula. For du, just remove all the divalent atoms. No need to add, no need to deduce the hydrogen atoms. Just we are going to remove the all hydrogen atoms. So that example is C3S6O is the students. Here one is the oxygen atom, divalent atom. So that to find the du, this formula is become a C3S6. Just we are going to remove the all the divalent atom. Next we can find out the du. So du is equal to what is the answer? 2 into 3 plus 2 minus it is a 6 upon 2. So 6, 8, 8 minus 2, 2 by 2. What is the answer? 1 degree. It means that one double bond is possible, one ring also possible. One ring also possible. So what are the, see that I am going to write the structures, all these structures. It is a CH3, CH2. Now it is a CH, doubly bonded O is there. See that number of hydrogen and number of oxygen atoms are same. So what is the du? How many pi bonds are there? 1 is there. So this is the first isomer. Second isomer will be written with the 3 carbon atoms CH3, CW bonded O. It is a CH2. Here also 1 pi bond is possible. Next example will be written CH2 W bonded. It is a CH single bond. It is a CH2. It is a OH also. It is one of the unsaturated alcohols. Then after getting unsaturated alcohols, we know that unsaturated alcohols and ethers. Unsaturated ethers are functional isomers of each other. Now, what is the rings are possible here? So that it is called cyclo. It is one of the cyclopropanol. It is cyclopropanol. Next, this is the one more compound I wrote. It is called oxyring. With the molecular formula C3S6, we got different after getting the du. I have written all these isomers. Next, case 3. It is a case 3. If any trivalent atoms are present, trivalent atom is present. Trivalent atom is a present. If any trivalent atom is a present, for du, remove all the trivalent atom, all trivalent atom, and also remove equal number of hydrogen atoms. Equal number of hydrogen atoms. See that very beginning, In case of monovalent atom is that we removed all the monovalent atom and added equal number of hydrogen atoms. Now here it is in case of trivalent atom is present. For D you remove all the trivalent atom and also remove equal number of hydrogen atoms. We will see one example. It is a C6 H7 N is the nitrogen is the trivalent atom. So remove all the trivalent atom and remove equal number of hydrogen atom also. One nitrogen is there. I am going to remove equal number of hydrogen atom also. So that I got a C6H6. We know that. Find out Du in this compound. It is one of the benzene. What is the benzene Du? You may get to one ring plus how many pi bonds? 3 pi bonds. What is the answer? Now this is called 4 degree we got. Next case number 4. Case number 4. In case of 3D structure, in case of 3D structure, what is the example here? In case of 3D structure, tell me. Therefore, du is equal to number of phases minus 1. These are the formula, students. In case of 3D structures, number of phases minus 1. So what is the du will come here? Du is equal to, it is one of the cube. 4 is the answer, 4 degree. So that compound name is called prismanities. The compound name is called prism. Next, example 2. Example 2. Is called cubane. Cubane it is. Is called cubane. Here also number of phases minus 1. Therefore, du is equal to number of phases will be 6. It is a 1. So du is equal to 5. Du is equal to 5. So in case of 3D structure, this is the formula. So this is called prism. This is called cubane. This is called